Hi everyone, and welcome to our IoT World Today webcast, How IoT Smart Sensors Allow Rapid Response to Emerging Threats of the New Post-Pandemic Era, sponsored by Libelium and Aridea. If you have any technical difficulties during today's session, please press the Help widget on your player console to receive assistance in solving common issues. If at any time you are having audio difficulties or issues with advancing of the slides, please hit your F5 key to refresh your webcast console. Today's webinar is being recorded and will be available on demand for 12 months starting tomorrow. You will receive an email when it is ready. Please feel free to submit any questions you may have for our speakers in the Q&A widget. Our speakers today are Anna Burnell, Business Development Director at Libelium, and Rob Moore, IoT Executive of Aridea. Anna is an industrial engineer focused on how IoT can change our world. She was a founder of Grupo Initec, which focused on implementing renewable energies in Spain, and has previously worked at IBM. She now defines and manages the business development of sales strategies at Libelium, as well as managing key accounts. Rob Moore is an IoT executive and a patented inventor of IoT technology. His passion has always been on improving the quality of life and work through technology. Rob has led several innovations in environment, healthcare, and manufacturing during his career. And with that, the floor's all yours, Anna.
Thank you very much for the introduction. I would just like to start talking to you a little about who is Libelium. Libelium is a company that was born around 15 years ago, and along these years we have been focused on designing and manufacturing a complete horizontal and interoperable IoT hardware platform. As we have been quite pioneers in the IoT market, we are probably one of the companies with more learned lessons in IoT sector, and for sure with recognitions as well. And our technology has been implemented in more than 120 different countries. And as we have been designing a quite horizontal technology, we have been able to participate in many different verticals in IoT sector. In fact, we are participating in smart agriculture projects, smart water, environment, cities, or parking, using not only our catalog devices, but also implementing custom projects with our amazing partners like Aridea in the United States. In fact, we have been working for the last few years in increasing our ecosystem of partners who are offering complementary products and services to Libelium ones. And we have been packaging complete IoT solutions in our initiative platform, the IoT Marketplace, where you can find out-of-the-box, end-to-end complete IoT solutions that has been packaged with the main target of making POC successful and scalable. And this is just the main summary of who Libelium is. And let's move to a slide just to show the way Libelium visualize the IoT world. A world connected thanks to spreading sensors everywhere, connecting cities, buildings, transports, factories, forests, rivers, countries, wherever, to internet. And from a Libelium perspective, IoT is not only for the city councils or for the CEOs, but also for the citizens and employees. The IoT is allowing data democracy and is helping to our politicians and our CEOs to take the better decisions. This is how Libelium sees the new smarter world. So, Susie, can you hear me?
Yep, and Rob, if we can move over to you.
Yes, absolutely. I'm trying to push my slide here to the audience. All right, here we go. All right. Welcome everyone. I'm Rob Moore, Vice President of Solutions Development at Aridea Solutions. Thank you for taking some time out of your schedules today to participate in the webinar. Before we begin discussing our exciting topics today, I'd like to give you just a brief background on myself and Aridea. Aridea is a U.S.-based IoT integration company headquartered in Charleston, West Virginia, in the heart of the Appalachian Mountains. Aridea was founded in 2013 by a group of IT professionals that shared a passion for technology and protecting our planet. Our motto is creating a smart Earth. We started our mission in helping protect the Appalachian Mountain Range and creating solutions for the coal mining industry to monitor their emissions in remote locations. Word quickly spread that Aridea had this magic technology that could allow the use of low-cost monitoring in places where it was not previously possible or cost prohibitive. Over the next several years, we will work on several projects to help protect the Earth. I'll quickly run you through some of our highlights. One of our projects was to help save endangered mussels for the U.S. Army Corps of Engineers. They quickly learned that we had a reputation for being stewards of the environment, so they were excited to have us help them with their project. So we built an IoT-based solution to help monitor the mussels, and the problem was that when they would dredge the river, the mussels would actually get covered in sedimentation from the dredging process. So what we did is we actually developed a monitoring system that sat on the bottom of the river to allow them to quickly identify when the sedimentation would get too deep, and then they would be able to control the dredging. Also, Aridea was also tasked to develop a methane monitoring platform to monitor an active leaking gas pipeline in Alaska. And this pipeline was actually in the heart of a beluga whale breeding ground. So in just under 2 weeks when the leak was discovered, we were able to actually deploy IoT sensors with cooperation from partners like Libelium. In just under 2 weeks, we were able to actually get a buoy in the water and begin actively monitoring this gas leak. Another project I like to highlight is we worked with a remote Indigenous community in Canada. They had repeated problems with their local water supply that got frequently contaminated by overflow events. They would accidentally overflow the reservoir, and they would have to boil the water for many weeks after each of those events. So we helped by putting in a solution that would actually report the depth of the water and send alerts to key personnel to let them know that the that the water had reached critical levels. And after we implemented the solution, they actually had 0 boil water advisories from that point. And more to current times, we actually just last year developed a technology in cooperation with Libelium to respond to the global pandemic. We created a fever screening solution that was used to protect thousands of workers and school children across the globe. So with that, thanks again for joining today. I'll hand it back over to Susie, and thanks for the joining.
Thanks, Anna and Rob. So it looks like we have a couple of questions already. Let's get started with our Q&A session. Anna, what are considered smart sensors? Anna, I think you're on mute there. If you can unmute yourself, please.
Sorry.
That's
Sorry,
right.
now you can hear me?
Yes, we can hear you. Yeah, so you were discussing what smart sensors are.
Okay, so before explaining a little, what smart sensors mean, I would like to explain a little what the concept Internet of Things means. Thanks to Internet of Things, in a standard configuration, we are usually connecting every single thing with sensors to Internet using different wireless communication protocols. And this IoT configuration is allowing us to feel or sense without the need of being there. The thing is that if we compare this standard configuration with our own sensorial human system, our brain is like a computer who is taking the decisions after receiving the information, the data that our senses are given. But sensor data themselves are just parameters with no meaning at all if it's not applied any kind of intelligence. That's why we move to the new slide to talk about a new concept, the binomium artificial intelligence plus IoT, Internet of Things. And if we didn't have enough acronyms, here we have another one, AIoT. And as I've just explained, we need to convert sensor data in valuable information thanks to including artificial intelligence. And now we have two possibilities to include artificial intelligence. One on the edge, on the sensors node, and the other on the cloud. The thing is that depending on the project, it's more suitable to choose one option than the other. And I usually say that we should ask ourselves some specific questions before taking a decision to choose one or other configuration. Probably the key question is to ask how fast do we need a reaction after measuring a data? Because maybe if we need a really fast reaction, we should select on the edge configuration. But this means something. The more intelligent the sensor node is, the higher the price, the higher the complexity, and more energy demand. So here comes new questions we should ask just to think about the right configurations. Do we have energy supply close to the sensor node, or we will need energy batteries? And how long will these batteries last? And do we have any kind of a restriction or limitation on sensor node costs? That's the second question. If we have this question solved, probably on the edge is one of the best solutions, but if we have some limitations on energy or on costs, we should go on the cloud configuration. And sometimes we have some additional limitations, for instance, sending our sensor data, maybe because this information is quite sensitive, outside of our company or outside of our country, or outside of our continent. And that means that on the cloud configuration should be very specific, ensuring that our sensor data will be stored in some specific servers located in some specific places where we feel comfortable. So depending on the project, we will be selecting one or other option of smart IoT technology.
Thank you. So Rob, why are smart sensors critical in the evolution of IoT? Oh, Rob, I think you're on mute as well.
Okay, great. Hey, I did get the slide quicker this time, so we're making progress. So no, thanks, Susie, for the question. And I think to properly answer that question, we need to review what the characteristics of a smart sensor is. So smart sensors are typically, low cost. That's one of the key factors of a smart sensor. So they can be economically deployed in large numbers. They're also physically small, typically in nature, so they can easily disappear, unobtrusively into an environment. Think of smart cars. They have lots of sensors that detect, lane changes and things of that. You don't really see them, but they're there. So that's a good example of, that characteristic. Also, wireless is a big characteristic of smart sensors. You don't want a lot of wires running, to all these different sensors in the environment, for aesthetics and also, for practicality. So wireless, is a lot of times a big characteristic. Self-identification and self-validation also are, if you have millions of these sensors there, you want a quick way to be able to provision these sensors, be able to keep track of them. Those are definitely valuable characteristics. They should also be very low powered, as Anna was talking. That's, in the past has been a big trade-off for computing on the edge versus, computing in the cloud. The sensors, have to be very low powered in many cases. Sometimes, surviving years, with just a single battery. They need to be robust, if they're going to be, especially sensing in the environment and outdoors, kind of going back to the cars, you're going to be going through car washes and environmental issues. You want those sensors to be, weather resistant. You want them, to not be susceptible to dust and water. So that's a very important characteristic. You want them to be self-diagnostic and self-healing capabilities. Also, data pre-processing. And this is probably one of the more important characteristics of the smart sensor is the pre-processing capabilities. So you want those to be able to make quick decisions, as Anna was stating, on the edge, for mission-critical type applications. So as far as how this is critical in the evolution of IoT, I kind of like to mirror, human evolution, in the, in my analogy of how this would work. So human evolution, we have developed cognitive capabilities, much like IoT, on the back end has, very high-end cloud capabilities that can make very high-end decisions about sensors, and take all that input and be able to, make decisions. But it's not necessarily very quick, but it's very analytical and it's very in-depth decisions, artificial intelligence, machine learning, things of that nature. But what's exciting to me about the evolution of IoT and these smart sensors is that essentially is the other half of humanity is like muscle memory, for example. In humans, if you touch a hot stove, you immediately have a reflex to move before you even think about it. So before that data can even be sent to your brain, you're going to move your hand, from that hot surface. And that's really where IoT is going, we feel, in the next 5 to 10 years, is these sensors are going to have intelligence at the edge that's going to be able to complete the puzzle of the sensors in the cloud. The cloud definitely has, a huge place in this, for the analytics, and the artificial intelligence and the analyzing the data. But the data really needs to be, there's short-term decisions, smart cars, back to that example. If, you're getting ready to be in a collision, you want your car to make an immediate decision. You don't want that data to go to the cloud and be subjected to undue latency. That decision needs to be made in milliseconds, on getting that information to the driver or to the braking system of the car. So yeah, that's really the exciting part of the evolution of IoT, how it mirrors humanity and our evolution. And yeah, I'm definitely excited for the next 5 to 10 years.
Thanks,
all right,
Rob.
Susie, back to you.
Thanks. So Anna, can you give us some examples of smart sensors that we all use today?
Well, yes, let me share with you a slide. No, it's not this one. Let me explain to you that after 15 years working in IoT market, we have seen a big evolution of IoT since the beginning, because at the beginning our customers were asking us as more as sensors as possible. The more sensors, the better. Even though they had access just to raw data with no meaning at all. And after these first stages where nobody knew very well the kind of parameters they weren't even measuring, customers require more accuracy sensors instead of number of sensors, accurate sensors. And now we're moving to a new stage of smart sensors where we need to implement algorithms to convert accuracy data in valuable information. So this is the natural evolution of IoT sensors. First, the more sensors, the better, then the more accuracy, the better, now the more intelligence, the better. And here you can see just an example of the new generation of the smart sensor nodes that Liberium is launching to the market. In the first one, we can see a smart parking sensor that is including a high-performance radar sensor that can be connected to many different software platforms where many different algorithms and artificial intelligence can be applied to even define or parking rates or even taxes when it's required, or even fines when someone is not compliant with a parking requirement. Wherever it's required can be applied on the software platforms. In fact, currently we are implementing one amazing project with this technology in Florida and the United States. Second one is our new air quality station that we expect to launch in the next few months. For Liberium, I would say that probably a smart environment has been one of the main verticals along these years. There are lots of interest in this vertical, and one of the big challenges in this vertical has been getting a high accuracy with using electrochemical sensors located outdoors, where it's very difficult to get this kind of accuracy. And in fact, with this kind of high performance, low price sensors, we were able, in the last generation of products, we were able to get ppm ranges instead of ppb's ranges of concentration in this kind of gases. Well, now we're launching this new product. We have been working more than 1 year in an algorithm of artificial intelligence applied in Liberium Cloud, just to convert these ppm's concentrations in ppb's concentrations. And we are really proud of this new step in artificial intelligence joined to IoT that we are doing with our sensor nodes. And the third one is our new generation of data logger, the Plug-and-Sense one. You cannot see a real photograph because we are now in the process of designing. This is just an infographic, but it will be the next generation of our existing data logger that we expect to launch just in the new months, a few months as well. And we expect to be a really competitive data logger in the market, because it will have the ability of detecting in real time the right sensor that any user is connecting, to charge the right firmware through internet. And in this product, we are moving intelligence not only to the sensor node, but even to the final sensor that will include small microcontrollers, each of them. Additionally, we are creating a new cloud that will help our system integrators, our partners, in the device management support that they need to give better services to the customers. And in all these cases, we are designing these new technologies, taking into account these three main common requirements. We are creating devices more configurable, just to make things easier to our customers, system integrators like Aridea, many of them. We are asking to program much less, just to make this easier. And we are creating devices with the concept of easier installation and maintenance. Because now that after 15 years working in real projects, we detect that this is a critical situation in the escalation of the kind of projects. So this, you can see just a few examples of the smart sensors we're creating right now.
Thank you, Anna. So Rob, can I ask you to give us a real-world example of how smart sensor technology was rapidly developed to respond to the current COVID pandemic?
No, Susie, absolutely. So let me get my slide here ready. We while working to understand the coronavirus, when it first appeared, and see how we could apply IoT. I'll kind of take you back to a story of my family and sort of how this came about. I was approached actually by a close family member, and they had come to visit. And I was aware that they had just started a new job at a major retail store. So I asked, how things were going, in regards to COVID-19 and his job. And he began to explain his day. And one part that caught my attention was he described how the retailer and a fellow employee had a handheld infrared thermometer, and that was used to screen the employees as they came into the workplace. And then he started laughing and described how he actually got a reading of 92 degrees Fahrenheit as his temperature, and then the person just waved him on to go into the building, which obviously it wasn't his correct temperature. He probably wouldn't be alive. So this kind of caught my attention, that it was very inefficient and unnecessary, and really seemed ripe for an IoT solution. Because of the human intervention and also the inaccuracy, of the data, and the potential danger, to everyone, at that facility. So I actually immediately engaged our team at Aridea to sort of deep dive into this use case and see if there's something that we could do. So first we analyzed the inefficiencies around that manual method. And, obviously, the first thing came to mind was it exposed the tester and the employee to potential harmful contact, by manually having to approach the person, to take their temperature. Secondly was an inconsistency on how the tests were being administered. Sometimes he described that, they would, press it against the person's forehead. Sometimes they would be 6 foot away from the person trying to take the temperature. So it was very inconsistent. And also, as we looked at how other businesses did that, we saw that, many times they were using very low-grade infrared thermometers to perform these tests. A lot of times they would buy them at the hardware stores that weren't even, made for human temperatures. They were made, to check air conditionings and drafty windows. So there was a large array of different things being used out there. So armed with this information, we began our search in our IoT ecosystem. Obviously, our first stop was Labellium, one of our valued partners. And we looked through their catalog, and we actually saw that they had an infrared thermometer that was being used for agricultural applications, made by a company called Apogee out of Utah here in the U.S. So we actually called them, and described, our idea of using their thermometer, in an IoT solution to scan, human temperature quickly and accurately. And they said, absolutely, that should work great. And actually, the sensor that we actually ended up using was actually used on the International Space Station to monitor crops. So definitely a very precision, highly accurate, robust sensor. So we actually began building what we called the Fever Kit. And we actually put this together in just under 3 weeks, from concept to solution. And that really shows the power of IoT, and having, a strong ecosystem and rapid platforms that, you can develop like Labellium that we can use. So, we were able to quickly put everything together and actually put it to market. and immediately began selling them. Yeah, we were kind of shocked when we put the product out, how quickly, that people just were starving for a solution, because people were concerned about, the close proximity of testing. And as you can see, the solution, the person just would approach the device, and then it would immediately give an indication of red or green, along with an audible indication of positive or negative results. And this shows the power of the smart sensor, and this is really what seeded my interest in smart sensors. So essentially, we took something that was made for the cloud, and to collect information for the cloud, and it's making a local decision and giving the person immediate feedback, whether they're safe to enter the building or not. So this is what really excites me about IoT is, you can put these sensors together in very creative ways, and make local decisions along with cloud-based decisions, and the combinations are pretty much endless, what you can do. So actually within just over a month and a half, we actually had deployed probably over 300 of our fever scanning stations, and we calculated they were scanning about 20,000 people a day across the world. And they were used by companies such as Toyota Motor Manufacturing, Georgia Pacific, Mylan Pharmaceuticals, and a lot of other high-profile businesses that were trying to get their employees back to work. And sort of to underscore, the edge computing aspect is, a lot of these employers were bringing in shift workers, over 1,000 at a time, so seconds, absolutely mattered in the interaction between, them stepping up to the device and it giving them an accurate reading and then moving in line. So it would be absolutely impossible to send that data to the cloud, have it analyzed and sent back, to be able to make that decision. So our solution was effectively deployed. It was used, as I said, many manufacturing facilities, also used in schools. A lot of municipalities used it for, public people coming in to, to do government business. It was actually used in our home county near Charleston, for our court system. So we were very proud of, and proud of our partners that we were able to, collaborate quickly and, and get that solution out in merely weeks, which would traditionally take years of development, So yeah, that's just one of the very exciting things about IoT. So back to you, Susie.
Thanks, Rob. So Anna, what would be the next steps to enable smart sensing technology in my business?
Well, I would like to share some of the main learned lessons along these 15 years and what we have detected as the 3 main reasons that motivates implementation of IoT in companies. First, for sure, earn more money because we are able to generate more business. Second one is save money because we are more efficient in processes. And third one, complying with legal requirements. These are the main 3 reasons because companies are implementing projects. And I think that the best way to show what kind of projects any kind of company can implement, I would like to share some examples that can inspire somehow the way we are implementing for any of these reasons IoT projects all around the world. Here you can see a farming project, a real amazing project that we have developed in one area of Russia with our smart agriculture technology. And the thing is that we have been controlling different parameters like temperature, humidity, pressure, just to control the environment where cows that are producing milk in a farm are living. And it's amazing to see that just in a few months, they have got an increasement of milk production around 18%. That means that 1 cow per day is producing around 28 liters, and they have got to increase to 33 liters, just making that the environment where the cows are living is more suitable for them. So this is just an example of making the business more profitable thanks to Internet of Things. And for sure, you can apply this in many other verticals. Let's go to another example. This smart water project has been using our smart water sensor nodes integrated in an aquatic drone in the Volga River in Russia as well, just to measure water quality parameters like pH, dissolved oxygen or conductivity, and some different ions, just to ensure the compliance with environmental regulation, but additionally, just to ensure that the information for citizens is transparent thanks to a blockchain system. So here we have a different approach with the environmental regulation. Compliance is the motor of this kind of projects. Let me share with you another ones that can inspire to some companies, or in this case municipalities, because here you can see a project, an IoT project that we have implemented in the north of Spain, in Huesca, where we have been using our smart parking sensor nodes just to monitor free parking spots for disabled people and to control if any unauthorized person is using this kind of spots. And this smart system was controlled by the local municipality, and additionally is creating different alarms to concern the police control center, just to take some kind of decisions of moving to some specific spot to find the person, or just to check that anything was correct in that spot. So this is another example that we are of IoT project that we are implementing in municipalities. Let's move to another one. In this case, is a smart water project that we have developed in New Zealand with one of our partners there. In salmon fish farmings, we are seeing some kind of repetition in this kind of projects, because we see that IoT can make them quite profitable. We have been assessing the different species of fishes that are created in fish farmings, and salmon is one of the species with more possibilities of making these kind of projects profitable with IoT. We have experience not only in New Zealand, but also in United Kingdom or in Norway. And in fact, with another species, with panda fishes, we have some experience in Vietnam. And the figures are amazing, because they have savings around 40%, because they are reducing the death of panda fishes around 40%, just controlling the environment where panda is growing thanks to our technology. So this is just a clear example of improving the profitability of one business that motivates to implement an IoT project. And let me finish one more example of one tracking project that we have developed in Spain with a logistics company that has been monitoring or tracking their trucks, and they have been identifying how long their trucks must be waiting for load or unload in the customer facilities, because they have identified that many times it's too much, and that has helped them to have the opportunity of negotiate pricing strategies with the customers based on the measurement results. So this is a clear example of process optimization with an IoT technology.
Thank you, Anna. So we've got some more questions from our viewers. The first one is from someone that has very remote equipment sites that they need to monitor for vital activities. What kind of communication protocols are available for this? So I'm not sure if Anna or Rob.
I would like to answer, but the first part of the question I didn't understand quite well.
This viewer has very remote equipment sites that they need to monitor for vital activities, and they're asking what kind of communication protocols are available for this.
Well, in fact, this is the typical question that everybody wants to have the right answer, and we always say that there is not a magic answer for connectivity. I think that it depends not only on the project, on the amount of data that they need to send in every frame of data, the speed of sending, or the location, because depending on the country or depending on the vertical, we prefer to use a different wireless communication protocol. I would say that, for instance, in agriculture, we have amazing problems to use cellular protocols sometimes in some specific areas, and it's not the same a project in Brazil or Indonesia that in the United States. And we, in this kind of projects, we always suggest to create a local network, probably with LoRaWAN or with an XB communication protocol, just to be sure that you are able to have some kind of connectivity somehow in some remote places. But if you need for some critical data, to be sure that data are getting on time to take the right decisions, we are offering and even suggesting to include even 2 different wireless communication protocols, just to be sure that in case that any of them is failing, you have the possibility of using other wireless communication protocols. And we suggest to make some kind of diversification about the band frequency that they are using. And in fact, we have some examples in fire prevention, for instance. Just a few years ago, we had some really sad news in Portugal, here close to Spain, where lots of firemen died in a very complicated summer of fires, because the band frequency that they were using to communication were overloaded, and they couldn't communicate and warn some of their colleagues that they should come back in some specific areas. So they finally died. And we have been working with some companies in Portugal, just suggesting to use a double communication protocol, one cellular, but one created, one local created working in a different band frequency, just to make sure that in an emergency situation, you have a second opportunity just to ensuring the communication. Another options, if you have to send some information with lots of data, like a video, you will probably have to choose a cellular option. You will not have another option. You cannot use a low power wideband option. So depending on the project, depending on the country, depending on the vertical, depending on the requirements of the project, we would suggest one or other protocol. And in fact, maybe Rob can confirm, because Rob is the one who is in contact directly with many customers, and he will probably have some examples like this.
No, absolutely no, and you definitely made all the right points. It definitely does depend upon your geographic location, how much bandwidth your application uses, video versus, just plain sensor data, and also, the infrastructure in those areas. If you have great, narrow band IoT cellular connections, that's, probably going to be the better choice. If you're in a very rural location, using unlicensed like LoRaWAN or other 900 megahertz, sub-gigahertz technologies and communications are going to be your better choice. So absolutely, it depends on the use case, but that's why we choose Libelium. They have a wide range of options in that area, but absolutely, it's very use case dependent.
Thanks. So we've got questions rolling in here. So someone's asking whether your companies offer a 360 type of solution in terms of software and hardware, and how you manage the hardware piece, taking into consideration installing sensors in remote locations.
Yeah, I can answer that from the Aridea standpoint. We are, with, I described the fever kit. We are developing new sort of self-included platforms like that. Many of them around smart water, which has been a lot of our solutions in the past. So yeah, we're developing algorithms along with the microcontrollers and the sensors all packaged in one bundle. And making those compatible with Libelium and other platforms out of the box. So yeah, we're very excited about creating a new generation of smart sensors based upon our experience and the new technology that's been made available.
And are any of your sensors equipped with BLE to enable interface to satellite gateway devices to enable worldwide deployment over Iridium?
Actually, ours, we are looking at, BLE as well as, local Wi-Fi interfaces, to the smart sensor, to be able to locally manage those. And, and obviously, that would allow for, flexible back-end communication options, such as Iridium. So no, definitely, that local interface to the sensor, as well as, the backhaul connections, are going to be critical and pretty much standard in any of our future solutions.
Thanks. So what are the top challenges of smart sensors that can be solved through customized software solutions? Perhaps, Anna, we could come to you for that.
Well, concerning software, Rob will add more value than me, but let me say that from a system integrator perspective, I guess that one of the most challenges challenges that they have to face is all the operational and maintenance of smart devices, because it's not as easy to modify or to upload the firmware in your office that when you have to move lots of kilometers just to the country, when you have just two sensor nodes controlling a smart agriculture binder. So I guess that device management is one of the big challenges that can help smart system integrators just to make scalable IoT projects. Maybe Rob, that is working really, really nice software platforms with Teralytics, can suggest more options.
No, I think you did a great job in explaining there. And plus, the question disappeared from my screen before I got a chance to read it closely. But no, I think I don't have much to add to that.
Well, I've got a question for you, Rob. That's now that the pandemic is hopefully winding down, what kind of new solutions does Aridea have to offer?
No, great question, and yeah, I sort of alluded to that in my last answer. But yeah, we're definitely looking to build off of our experience in smart water, and also what we learned from the Fever Kit, and being able to deploy technology that can make quick local decisions and have local management. So yeah, we're looking and actually currently developing an array of smart sensors that around smart water that will detect water quality and also abnormal water movements for safety in pools or in water features that are unattended for security reasons. So yeah, we're definitely excited about those type of solutions. Most of them will be focused around smart water, but we've also had a lot of requests for weather monitoring solutions and some air quality, as I know Libelium is developing as well. So no, definitely stay tuned, and we'll have some exciting solutions here. We're hoping by third quarter this year.
Great. So how do you balance battery life with power requirements for edge computing?
So yeah, I can give that a shot, as we'll say, and then yeah, Anna probably could add more to that. But definitely, the computing power, directly, typically, will affect the power requirements. That luckily the technology is really sort of bending that curve. There's a lot of systems on a chip and technologies, MEMS technologies that allow some pretty good algorithms to be ran at the edge that do not require a lot of power. So that is shifting. But yeah, definitely, the power requirements and the amount of compute that's done on the edge, is always going to be a challenge.
And are any of your sensors certified for IEC 67911 intrinsic safe operation?
From my side, I don't know exactly this kind of certification. We have published all the certifications that we have all around the world. We have all the electromagnetical certification and as well some of the connectivity certifications. In the United States, we have certifications with AT&T, for instance, and PCRB, additional to FCC, for instance. So these are the typical certifications that we have in the United States.
Thank you. So our last question today is perhaps one of you could discuss a little bit security at the edge, both physical and network.
Yeah, I was going to say I can start that. Definitely, that is a huge consideration. We see in the news every day, of companies, security being breached, and definitely, a lot of them are IoT based. We had a large, refinery. And a pipeline here in the U.S., was taken offline. Not necessarily IoT, but it could very easily have been at the edge where where those exploits happen. So yeah, definitely very important to make sure that encryption is exercised at every layer in the solution, between the sensor and the sensor nodes, and then obviously onto the cloud, and making sure that any interfaces that are open to that device, the more flexible we make these sensors, the more vulnerable they are, to unattended access, by people that are trying to do, harm to your system. So absolutely, security needs to be baked in at every layer. And at Aridea, we're definitely doing, our homework on that. And I know that Libelium, that's an important feature in everything they do as well.
Yes, for sure. Our engineering department is working always in updating firmware just to be sure that all the security is taken into account in all layers that we are working with.
Thank you. So we got through all our questions just in the nick of time. Before we go, I'd like to thank Libellium and Aridea for sponsoring today's event, as well as Anna and Rob for the informative discussion. Just a reminder that this webinar will be available on demand starting tomorrow, so please feel free to come back and review it. Have a great day, and thank you for joining us.
Thank you very much to everybody. Bye.